Welcome dear students. Today we are going to discuss about phase diagram of water system। और जैसे कि हम जानते हैं कि जो वाटर है वो तीन फेज में एग्जिस्ट करता है, सॉलिड, लिक्विड एंड गैस, और वी कैन से इट एज आइस, वाटर एंड इट्स वेपर। ठीक है। सो अगेन अगर तीन फेसेस हैं तो उनकी तीन फेज बाउंड्रीज भी होंगी, बिटवीन सॉलिड एंड लिक्विड, between liquid and gas, and between solid and gas, which is represented by their corresponding. The phase boundary represents the melting or freezing, or similarly either vaporization or condensation, or we can say sublimation or deposition. So let us discuss in detail what are those phase boundaries and what these points, triple point, critical point indicates. Now this is the phase diagram of a water system. Here starting from point O, triple point O to A. So this represents the vapor pressure curve. Okay. And this is the boundary between what? Liquid or water and gas or vapor. Now calculating the degree of freedom on this line, we have one component C will be equal to 1. We have two phases, liquid and gas, plus 2. So this will be 1. That means the degree of freedom on this phase boundary OA should be equal to 1, and this is a univariate system. So curve begins from point O, which is at 0.0075 degrees Celsius under 4.578 mmHg pressure, and this terminates at point A, which is nothing but the critical point. What is critical point? Critical point is the point above which there is no phase boundary between liquid and gas exist. So the water component exists in a supercritical fluid state, where he can't be stated as a liquid, neither as a liquid nor as a gas. So the critical point of water is at 374 degrees Celsius at 280 atmosphere. Now looking at curve OB, this is called as a sublimation curve. And why sublimation? Because here it represents the phase boundary between solid, ice, and gas, which is vapor. So here again this boundary is a univariate system. That means the degree of freedom here is again 1. Now looking at curve OC, OC, as you can see, this is inclined towards the pressure axis. So that means what? As we can see, this phase boundary indicates these are the points where solid melts to liquid. So as soon as like you start increasing the pressure, okay, your melting point starts decreasing, right? So the melting point curve, this goes up to point C, where at higher pressure like 2240 atmosphere, the melting point becomes minus 22 degree Celsius. And similarly, like at this point, your 1 atmosphere, this is lesser, higher than that. Okay, so this inclination towards the pressure axis indicates as you increase the pressure, your melting point decreases. Now we have a curve OA dash. If we extrapolate this curve OA, okay, this becomes OA dash, which is called as a metastable equilibrium. Why we call it as a metastable equilibrium? So we are like decreasing the temperature without disturbing the pressure. So what is happening here? It follows the line over till A dash, and this is in a supercooled liquid state. So in a supercooled liquid state, as soon as we disturb the medium or add a small crystal of ice, this curve OA dash disappears and this changes into OB. That means the phase boundary again becomes visible between solid and gas. And as we have discussed earlier, this triple point O indicates that all the three phases, solid, liquid and gas, they coexist at this single point. So what will be the degree of freedom here? We have three phases, we have one component which is H2O. So again, using the Gibbs phase rule, C minus P plus 2, we have one component, we have three phases plus 2, so that becomes 0. That means at this point this is a invariant system. So if either temperature or pressure be changed, then one of the three phases will disappear and the phase boundary again becomes visible. Now let us look at the regions. Previously we were looking at the boundaries, phase boundaries. Now look at the region. We have AOC, from going from A going to O and C, and we have AOB region. Now here the line XA and XB that represents the formation of liquid from this phase boundary. That means as soon as the vapor leaves this phase boundary towards A or B, so there will be a cooling of liquid. Hence above this area represents the liquid phase, and below this from X to Y and X to Z, that represents the formation of water from the liquid phase. Similarly, now look at the BOC region. This is B, O and C region. Here we have X dash A dash to X dash B dash, and that represents the formation of solid from vapor. So similarly, XY dash and XZ dash, that represents the formation of vapor from solid phase. Hence below this curve there is a presence of gas only, and above this curve we have only solid, and that is why this is called as the sublimation curve. That means the solid is either directly converted into gas or the gas is directly converted into solid. So this is what about the phase diagram of a water system. Now if you look at the effect of change of temperature at a particular pressure. Now assuming the water is at 1 atmospheric pressure at point X, the system is in solid state. That means it will be in bivariant system. Applying the Gibbs phase rule, F will be equal to C minus P plus 2. You have one component, you have one phase only, so that freedom will be equal to 2. This is a bivariant system. Now at this constant atmosphere, if we start increasing the temperature on continuous heating, so meeting at point Y, the ice will start melting and the liquid phase will start appearing. Okay, now the system becomes univariant. So on continuously providing the heat, your all of the ice will convert it into water. So till when all of the ice gets converted into water, the water will remain at point Y, and when they will convert it, it's started shifting towards Z, and this again becomes a bivariant system. Similar thing happen at point Z. Your all of the liquid will start changing into gaseous phase, and as soon as all the liquid gets converted into gaseous phase, this again becomes bivariant, going from Z to Z dash. So at these point Y and Z, this is a univariant system. At point X, at point Z dash, they becomes a bivariant system. So we have discussed about the phase diagram system also of a water, where it was important to know at which particular atmospheric pressure or at which temperature the water is in either solid state, liquid state or gaseous state, and what are those phase boundaries. And this is important to know that this curve OC dash, this should be inclined towards the pressure axis, because on increasing the pressure, your melting point should start decreasing. So thank you students. I hope you like the video. In the next slide, we will discuss about the phase diagram of a sulfur system.